In lesson 56 today, we are going to get a new formula for finding the area of triangles. So then we will have a choice. We can use the one we've been using forever, or we can use this new one depending on what information we're given and what we need to find. We're also going to learn how to get the area of some sort of a segment. And it's not going to be a line segment because lines don't have any width, so that can't have any area. So it's going to be some other kind of a segment. And then we're going to review systems of inequalities, where we have to graph those and shade the area that solves the system. So first, let's do not quite an area of a triangle, but let's do an area of a trapezoid. We're not going to get a new formula for this, but we're going to put together ideas that we already know to be able to solve this. So we know area of a trapezoid is 1/2 base 1 plus base 2 times the height, and no real problem plugging in that the 8 and the 13 are parallel sides. The problem that we have, 6 is not the height. Height must always, no matter what shape, make a right angle with a base, and 6 does not. What we need and don't have would be how tall that is. So who can help me come up with a strategy? How might we figure out what that h is, just as you look at this picture? Thinking about things that you already know, what could you do, Melina?
Well, like the bottom of the triangle is going to be 5 because 13 minus 8.
No, because that 8 would be this part, and the 5 is somehow this piece on the left plus the piece on the right, and we don't know how it splits up, and we have no way of knowing that at this point, huh?
Trig.
We're going to use trig. Which trig ratio should I use? So if I write down sine of the 26 degrees, it needs to be what? H over 6. So we're not going to punch this in the calculator separately. I'm simply going to then write the 6 sine 26 in here in the formula. I could do a little bit of this mental math if I wanted to. I have 1/2 times 21 times 6, so I think I'll do the 1/2 times 6 is 3, times 21, sine 26. Now punch that in your calculator. You could have punched it in like that, but by the time you do the parentheses, it's a little faster if you do a little bit of easy mental math on there. Amy, what do you have?
165.7.
Say that again. All right. 27.617. That sounds a little bit better. Anybody else get that? Give me thumbs up, thumbs down. And units are meters, so area is meters squared. So no new formula with that one, just thinking about, oh, this time they didn't give us the height, or what they gave us, but they didn't on trapezoids in previous years, the degrees on one of those angles. That's what made the difference, that they also gave us the measure of one angle in there. Okay, now let's think about a triangle. We're going to do the same idea here, but then we're going to look at it and see if we can speculate on this new formula of what it might be. Again, I know that the area of a triangle is 1/2 base times height, and it's easy enough to put the 16 in there as the base, but what we don't have is the height. So Melina, what should I do for the height on this one?
Sine 42.
Perfect. Sine 42 is the opposite over the hypotenuse. So h, and we're not going to solve this separately or anything, we're going to write that down right here, the 12 sine 42 degrees, and punch that in your calculators for me, all in one line. You can do the 1/2 if you want, or you can go ahead and do 8 times 12 times sine 42, or you can do 16 times 6 times the sine of 42. And raise your hands when you have that. Molly, what'd you get?
64.227.
Anybody else? Thumbs up, thumbs down? And that will be inches, and that will be square inches. Now let's look at what we wrote down that you just typed in your calculators. What you just wrote down was a half. 16 was one side of the triangle. 12 was another side of the triangle. And what's special about 42, it was the angle in between those two sides. If I draw just the 12 and just the 16, I have that 42-degree angle. So this was the angle between those sides. And that is what I hope is my new formula. I'm going to do it with letters to see if I can prove it. For a triangle like this, where I've got the 42 is an acute angle, and then the tricky part, I'd sure like the formula to work on any triangle, even if it's got an obtuse angle right there. If it's a right triangle, I'm still going to do 1/2 base times height because I've automatically got the two sides that make the 90 degrees. But otherwise, I may want to use this formula. So let's label this one similarly to what we just had. Here's an angle, and here's the base, here's another side, and I would like to show that the area needs to be 1/2, one side times another side, times the sine of the angle in between those two sides. So what we just did was we drew in the height, and we started with the area would have to be 1/2 the base times the height. And we figured out that the sine of C would have to be h over a, so that means that h would have to be a times the sine of C. And doesn't that give me 1/2 times one side times the other side times the sine of the angle in between? So it worked there in general when that was an acute triangle. Now where it gets a little bit strange, if my C that I know is right here, and these are the two sides that I know, I'll put the base down there on the bottom again. So there's my C, base down there. For this one, if I draw the height for this triangle, I have to draw it out here. And I know that it needs to be true that the area has to be 1/2 the base times the height. But if I start looking at my right triangle so I can do my right triangle trig here, this angle inside my triangle isn't C, it's 180 minus C. So on this one, if I take the sine of 180 minus C, that's going to be the opposite over the hypotenuse. So h is going to be a times the sine of 180 minus C. So I don't quite have the same formula at this point, do I? It's close. But now I want you to think about what you know about the unit circle. If I had some angle C right here, I could draw a congruent little angle like this over here, and that part's C, which would mean that all the way around here would be the 180 minus C. So if this was on my unit circle, sine is what? X or Y coordinate again? It's the y coordinate for the sine. And so if I was on this side, I'd have this for my y coordinate. And if I was over here at 180 minus c, wouldn't I have the same y coordinate? So it is true that the sine of 180 minus c is the same as the sine of c. So that means I do have the same formula. 1/2, one side times another side times the sine of the angle in between. So let's put this in your formula list. And what we have just done is to verify we can use this whether C is acute or obtuse. Now with vectors you have to do it with acute angles. But for these, you can put any angle between 0 and 180 in there when you're using this new triangle area formula. So let's try this out on an example. We have a triangle and we need to find its area. And from this point on, when you find area of a triangle, you choose 1/2 area, or 1/2 base times the height, or 1/2 one side times another side times the sine of the angle in between, depending on what information you know. For this one, I know 2 sides and the angle in between. I do not know the height, so I'm not going to use 1/2 dh. I'm going to use my new formula. I am going to say that the area is 1/2 one side times the other side times the sine of the angle that is in between those 2 sides. And now all you need to do is to enter that on your calculator. You may enter it just like that, or you may do some quick mental math. 1/2 times 14 is 7, times 10 is 70, and just enter 70. Sine 130, and raise your hand when you have that. And I'd like every hand up, please. Olivia, what do you find?
53.623.
Thumbs up, thumbs down from others? Looks like that's verified by your classmates. Meters squared. And see how that saved us a little bit of time to have that new formula. If it's trapezoid, you still have to go through and find the height using trig and plug into the trapezoid formula. We don't have a new one for that. All right, let's move on then to this new kind of segment. A segment of a circle looks like a little bit of the pie crust on a piece of pie. It's partly formed by the curve of the circle and partly by a straight line that connects those 2 points, so a chord, and the part of the circle between those 2 points, between the endpoints of that chord. So you can see how that does have a little bit of area. If it's a bigger angle, a segment might look like a really, really, really fat pie crust on there. Like there wasn't much filling really in the middle of it, but it was mostly all crust or something. Depending on the size of the angle, will determine, you know, how fat that segment really is. Okay, right now I don't have any numbers on there, but I'll move this shading in a minute so we have some numbers. First, let's come up with a strategy. If we wanted to find the area of that shaded part, how would we go about that? Ever since at least Algebra 1 and maybe pre-algebra, you've been doing composite areas where you take the area of this shape plus the area of that, or the area of this shape minus the area of that. What could be a strategy for this one to leave us with just that shaded part? Samantha, you have an idea? If I wanted just the shaded part, how might I get there? So not from the circle, but from the piece of pie. I could take the sector minus the triangle to get the segment. Give me a thumbs up or thumbs down. Do you think that would work? And you're probably starting to notice right now, you need to read these carefully. Sector and segment. Some problems will ask for the whole sector, the whole piece of pie, some just the pie crust. Question?
What is the difference between the sector and
The sector is the piece of pie. So if I took this whole piece of pie here, and then subtracted the triangle out of that, I'd have just the black part. So that's our strategy of what we're going to try to do. Thumbs up, thumbs down, are we good with that? Can we visualize that? Okay, so we're going to add some numbers in here. If we want to do a sector, we already know that that is the fraction of the circle, the central angle over the whole circle, times the area of the whole circle, and then minus one of our triangle formulas, either base times height or AB sine C. So let's take a look at what they give us. They tell us what the central angle is, so we know what theta is, and they tell us that the radius is 8, so we know these two sides. So what do you think? Old formula or new formula for the area of the triangle? The new one. We don't know what h is, so we're going to take 1/2 AB times the sine of theta, but A and B are going to both be the radius. Now, what's a little bit different on this is that central angle is in radians. So if I take 1/2 of a radian, the whole circle in radians is not 360. How many radians in a whole circle? So I need to take the 0 out of 2 pi, since I happen to know my angle in radians. And then that is going to be times pi times the 8 squared. And so let's see, I've got 64 times 1/2, that's 32. Over 2, that's 16, and the pi's cancel. Are you comfortable with that close to 16? And we don't even need the calculator for it. Now we have minus 1/2. The two sides we know are both radii, so 8 times 8. And then we need to do sine of that angle. So we could do sine of 0.5 radians if we change our calculator settings to radians. And if we leave our calculator on degrees, we would have to change that to degrees, so that would be 0.5 radians times 180 degrees in pi radians. So we'd have 1/2 times 80, or 1/2 times 180, so 90 over pi. So how about we split the room in half? Everybody from here over to the windows, you do 16 minus, and let's see, 64 divided by 2 is going to be 32. So everybody by the windows do 16 minus 32 sine 0.5 radians. Go up to that top corner, just move your little cursor up there, and then click, and it'll change it to degrees. And everybody from here over towards the hall, you enter 16 minus 32 sine 90 over pi, and leave your calculators on degrees. And we should get the same thing both ways. Everybody understand how you can quickly change your settings? Just move the cursor, click enter, and then once you're done, you can move the cursor up there and move it back. Tosh, what'd you get?
15.4, or 341.
And you entered 16 minus 32 sine 90 over pi. Maddie, what'd you get?
0.658.
0.658. Others up here who did degrees, 0.658. What about with radians? So we got the same thing both ways. 0.658, and these were feet, and this was area, so square feet. Anybody with a question on that? We had several things that came up. We have to pay attention to what kind of units are we working with and how's our calculator set. Also, not really something new, but we had to pay attention if we are trying to get the area of a sector. So this is a piece of pie. It is the central angle over the whole circle times pi r squared, like it's always been. Except if it's in radians, we do the central angle in radians over the whole circle in radians. So theta over 2 pi. Okay, last topic for today, solving a system of inequalities. We're talking about points now, and they're infinitely many, so we can't list them all. So all we do is to shade the right part of the graph. And first off, what is the difference between how I show less than or greater than compared to how I show less than or equal or greater than or equal? Who remembers when we are doing inequalities? Evelyn?
So just less than and greater than are dotted lines, and then less than or equal to, and then greater than or equal to are like solid.
So if we have the equal bar, we do solid, and if we don't have the equal bar, we do dotted. So top one, solid or dotted? Dotted. If we didn't worry about the inequality, if it was just y equals a third x plus 3, do we know what that graph looks like? Everybody shout out. Is it a circle or what? It's just a straight line. So y-intercept of 3, slope of 1/3. It is important that you graph these carefully and accurately. So that means if it is a straight line, use a straight edge. Otherwise, if it is something with a curve, you do the best that you can to plot points and make it as accurate as you can. So there's our line. Whoops. Didn't hit the line thing. Get that. That looks a little bit straighter. So far, so good. And make a prediction for me. So there's a line. And just for that line, I need to graph y is less than that line. Above or below, everybody point. Which way do you think? And I'm going to graph all of the y's that are smaller than the line. The y's are your vertical, so if we're smaller than the line, we're pretty confident we're going to need to shade below that line. But we'll do a test point before we're completely finished to make sure. Okay, what shape do I have for the second one? I have a y that's not squared and an x that is squared. What shape is that? So a parabola. So we need to get it in vertex form so that we can see what it looks like. We don't need to write out all of the things that we did when it's just graphing one, but enough that we can plot some points. So I need to look at y minus 2, and I'm going to work through for right now just with an equal sign so I don't confuse myself. X squared plus 4x. What needs to go in my short parentheses? X plus 2, and if I square that, I have x squared plus 4x plus 4. Add 4 over here, so I have y plus 2 equals that. So y is x plus 2 squared minus 2. So what is my vertex? Everybody. Negative 2, negative 2. Will it open up or down? So negative 2, negative 2. And it needs to open up. Okay, we need to get a few points. We know this is my axis right here. And if I put 0 in for the axis, what's y? So I know my y-intercept is 0, 2. So by symmetry, I have this point just barely up above that. And then I think I'm just going to do an XY chart to get something else. So maybe if I put 1 in for X, then I'll get something kind of out here so I can get it going a little bit farther. So then I'm going to have 1 plus 4 plus 2. So 5 plus 2 is 7, so 1, 7. And by symmetry, 1, 2, 3, 1, 2, 3. And this needs to be solid, we said. So I'm going to just draw that in with a solid line. So far, so good. And by the way, if you ever draw solid and then it's like, oops, that should have been dotted, try to erase it, but if you're unsure whether I can tell, you can always write, I meant that to be dotted, just to make sure it's clear to me what you did for that. Because sometimes it doesn't erase clearly enough to see. Okay, so for the parabola, y is greater than or equal to the parabola. If the y's are greater than the parabola, is that above or below the parabola? If the y's are bigger than the parabola, the y's, the vertical part, need to be above. I think it is easier to think about it with above and below, not inside and outside. Because if I have an upside down parabola, below is inside. For this one, above is inside. And so above and below are clearer with what the y is. So if I think I am above the parabola and below the line, I think that means I'm talking about this part right here. That much makes sense to everybody. So we're going to pick a test point and check it in both equations. So how about -2, 0? Is that as good as anything? Cannot be on either of the lines. And we write down what our test point is that we're choosing to use. And then we need to show it in both equations. So I need to put a -2 in for the x, a 0 in for the y. So 0 less than -2/3 plus 3. Is that true? So it works for the line. Now for my parabola, I'm going to put 0 in. Is 0 greater than or equal to? If I put a -2 in for the x and square it, I have a 4. If I put a -2 in for the 4, or for the x, I have a -8. And then I have a +2 out here on the end. And 0 is greater than or equal to 6 minus 8, -2. Is that true? So it worked for both equations or both inequalities, so that region is correct. If you are asked to graph the inequalities, that's all you do. You do not label your regions with any letters like I'm about to talk about. But sometimes the book gives you the graph and says which part would satisfy the graph. And it does not matter, they change the order of the letters around all the time. A, B, C, D, they could do M, N, P, Q. There's no set pattern to that. But they will pick one letter. So maybe they did an A that was above the line and above the parabola, or in this case, above and inside. Maybe the region that we picked they called B, and B was below the line and above the parabola. Maybe they put a C here below both of them. And then there's always one that's a little bit confusing. And so let's see, it would have to be below the parabola and above the line I haven't talked about that one yet. That would need to be above the line and below or outside the parabola. It would be split into two parts because that parabola keeps going forever and ever. So you see how that's kind of split in two parts? So if the book gives you the graph, they'll label it like that. You don't need to recopy the graph. You would simply say, I think it's B, looking at the less than's and greater than's, write down a test point and do the check. So if they gave you the graph, that's all that your work would have to look like. If they give you the inequalities, you'd have to do whatever to draw it and shade it, and then don't worry about any letters. Questions from anybody?